طيب يعطيكم العافية جميعا. اليوم إن شاء الله رح نحكي آخر توبيك من محاضرات الميديسينال كيمستري 2 وهو توبيك الأنتي فايرال. أنا بعرف بعض الشعب أخذت وبعض الشعب ما أخذت الجزء من هاي المحاضرة، فبالتالي أنا بدي أسجل من بداية هاي المحاضرة إن شاء الله ونعيد المحاضرة للي ما أخذوا. يعني بإمكانكم تقدموا الفيديو للجزء اللي بلشتم أو انتهينا منه في المحاضرة، أو الجزء اللي انتهينا منه في الأنتي فايرالز، واللي ما أخذ المحاضرة بإمكانه يرجع للمحاضرة من البداية. طيب اليوم راح نحكي عن انتي فايرالز بشكل عام، وراح نحكي عن الفيروسز ونعرف الفيروسز ونعرف اللايف سايكل تبع الفيروسز، وبعدين راح نتعرف على بعض الانتي فايرالز. ودائما انا بحب قبل ما ابلش الانتي فايرالز توبيك اني احكي بشويه معلومات عامه. الانتي فايرالز هم ادويه لا تشفي ولا they don't cure viral infection, and what they do basically they reduce the viral replication to a point where you don't get severe symptoms or you don't get symptoms at all. So they can't work on clearing totally the viral infection. What they do is just to reduce that viral infection or virus counts, and then that would reduce the symptoms that you get from this viral infection. They can't clear it totally for various reasons راح نحكي عنهم لما نحكي عن antivirals. فالانتيفيرالز على عكس الانتيميكروبيال agents, for example, they cannot clear the viral infection totally. What they do is to reduce the symptoms and reduce any severe complications you get over time from infections, whether that's a serious viral infection or just a simple viral infection. بالعادة الأدوية الانتيفيرالز ما كان فيهم successful stories إلا بمرضين فقط، بنقدر نحكي كان فيهم successful stories of reducing the burden or the disease or the pathogenic of those viral infections, اللي هم two diseases حكينا عنهم: hepatitis C and HIV. Hepatitis C and HIV, they used to be lethal diseases. When you get those diseases or when someone get those diseases, one of those diseases, they can likely die within 5 years of this infection, of the initial infection time. For example, HIV patients would progress to the advanced stage, which is an AIDS or acquired immunodeficiency this stage where patients would lose their immunity almost totally and start getting diseases, multiple infections, sometimes cancer, and they pass away from the complication of HIV. However, nowadays, if the HIV is discovered very early on in these patients, they can be put on medications, different medications, antiviral medications that allow them to live almost a normal life up to their 70, 80 years old, whatever age they have. So basically the antivirals did do a good job of reducing HIV complications. This is one disease. The second disease اللي هو hepatitis C، وهو مرض التهاب الكبد الوبائي C اللي منتشر في مصر وفي أماكن أخرى أيضا بأفريقيا. بوجود nowadays antivirals that reduces the complications of liver damage and cirrhosis over the years, and so patients live normal life, almost normal life for the rest of their life. طيب خلينا نحكي شوية عن شو هم الفيروسز. هل هم الفيروسز؟ طيب شو هم الفيروسز؟ الفيروسز are living ولا non-living? They are living and non-living. They are non-living if they're outside the cell. If they're inside the cell, a living cell, they would be living parasites or organisms. So viruses are obligate intracellular parasites. They are obligate intracellular parasites. They are inside. They have to live inside the cell to be able to copy themselves, replicate, and expand. So basically, viruses needs another living cell to survive on. They can be defined as submicroscopic entity consisting of a single nucleic acid surrounded by protein coats and capable of replication only within living cell. So they only can replicate inside a living cell. Size-wise, viruses are smaller than bacteria, and they range from 20 to 300 nanomolars. And there are different types of viruses. There are viruses that live in human cells that we know about. There are viruses that live on bacteria cells, and these are called as bacteriophages. And viruses that live on fungal cells that we call them as microphages. There are even some viruses that we call them variophages that infect other viruses, basically, which are a small number of those viruses, very rarely seen, but there are things like this exist, like variophages. The origin of viruses are believed to be either plasmid or bacteria. It's not well understood, but it is a belief that scientists have as well. And we only know about small percentage of the viruses that exist on Earth. We only know about 5,000 species of viruses. كم هدول represent من عدد الحقيقي للviruses? We don't know exactly, but it's believed that's about only 1 to 2% of the viruses that we know. Oh, sorry, the ones that we know are representing only 1 to 2% of the total virus. يعني أنواع السبيشيز اللي موجودة على الكرة الأرضية. فبالتالي if we want to estimate the species number, the real species number of viruses on Earth, you're probably gonna be more than 1 million type of species. But we only know about 5,000. And the reason why we only know about 5,000 because basically you only detect viruses that cause pathogenesis or cause symptoms to you. They cause certain disease. The ones that we don't cause symptoms, we truly don't know about them most of the time. That's the reason why. Now let's look at the structure of viruses. The structure of viruses consists of, as we mentioned in the previous slide, nucleic acid. And nucleic acid can be either DNA or RNA viruses. And a DNA or RNA viruses. A DNA viruses can be double-stranded or can be single-stranded DNA. So there's two types. The double-stranded is more common than single-stranded. بس لو بدنا نقارن بكل nucleic acid مين more common DNA ولا RNA viruses? RNA viruses are much more common than DNA viruses. Okay, they are much more common than DNA viruses. So this is the first component اللي هو nucleic acid. The second component اللي هو اللي هو الcapsid, and the capsid basically covers is a protein that covers the nucleic acid. So we have a nucleic acid over here, whatever that genomic material, and then we have a capsid that covers that nucleic acid. This is a protein that covers this genomic material, and sometimes we call it as nucleocapsid. The reason why, because it covers the nucleic acid material, so we call it as nucleic acid. And it's a protein that composed of a single monomer. We call it as capsomers. We call it as capsomer. A third layer فعليا that could exist in some of the bacteria is envelope, and envelopes are glycoproteins that are sandwiched or covered between two layers of lipids. So basically glycoproteins covered with a lipid bilayer. And not all bacteria, it's some bacteria only might have envelope, some of them might not have envelope. So we could classify the bacteria based on nucleic acid type, whether it's DNA or RNA bacteria. We could classify bacteria also on the envelope, whether it has an envelope or it doesn't have an envelope. It's called non-envelope versus envelope as well. And we could classify the bacteria based on the disease they cause and so on. لكن لو بدنا نحكي عن nucleic acid, which is the most important type of classification, DNA versus the RNA bacteria, what we have here is DNA viruses. For example, let's look at DNA viruses. Example عليهم لما pox virus, herpes virus, adenovirus, papilloma virus as well. طيب الهيربس فيروس خلينا نحكي عنه لأنه يمكن one of the most common viruses بالDNA viruses that we know about a lot. Herpes can be different species of herpes viruses. عندنا, for example, we have varicella zoster virus, and that varicella zoster virus causes chickenpox, and it causes as well shingles. صح؟ chickenpox اللي هو مرض جدري الماء, والشخص لما يكون عنده جدري ماء وما بظل الفيروس موجود latent موجود بالجسم بالneuronal ends, and it could be under certain circumstances when the person has lower immunity, they could get shingles again from varicella zoster. We do have other types of herpes. We have herpes simplex virus type 1. We have herpes simplex virus type 2. So these are different type of herpes viruses. Type 1 causes اللي هو الحمو اللي بيجي على الثم. تمام, الحمو اللي بيجي على الثم. الherpes 2 virus is basically an STD, sexually transmitted disease, that could cause what we call as genitalis herpes. And this is different than herpes 1. 2 is different than 1. تمام. Genitalis herpes is a sexually transmitted disease that is usually affecting people who are sexually active in an uncontrolled manner. And there's studies that shows about 60 to 70% of people that are sexually active have herpes 2 already. بينما herpes 1 موجود بالعالم بشكل كبير. حوالي 95% من الأشخاص بالعالم believed to have been infected with herpes virus, simplex virus 1 type 1 at some point in their life. Papilloma virus as well is well known. And لو بدنا نحكي عن DNA viruses, كيف DNA viruses usually infect the cell? They have double-stranded DNA or single-stranded زي ما حكينا, and the virus enter the cell nucleus and direct the generation of new virus. So the DNA تبعت الفيروس DNA virus بتدخل جوا النيوكليوس تبعت الهيومن, تمام, وبتصير تعمل copies of DNAs of another DNAs as well, and then it's sent to messenger, and there is to get more messenger mRNA outside and copy the proteins. This is how DNA viruses work. But they have their DNA material inserted inside the nucleus of the human cell. وبنعمل منهم copies of those DNA, and then we do the transcription process to generate mRNA, and then we do translation process. This is how they replicate inside the human cell. طب كيف ال RNA viruses replicate inside the human cell? They don't have DNA. They do have an enzyme that we call reverse transcriptase, and that reverse transcriptase enzyme is an enzyme that would convert ال RNA تبعهم لما يدخلوا جوا الخلية خارج النيوكليوس, بيحول ال reverse transcriptase enzyme RNA to DNA. It converts the RNA to DNA. And that DNA copy of the viral RNA is then integrated into the host genome اللي هو cell nucleus. بتدخل جوا النيوكليوس that DNA inside the nucleus, and we get more copies of it, and then we do transcription to generate mRNA, and then we do translation to generate protein. So they are different how they infect human cell. The RNA needs reverse transcriptase enzyme that reverse the process of RNA to DNA. Reverse means reverse copying the RNA back to DNA, and that DNA goes inside the human cell وبصير له transcription and translation. بينما ال DNA directly بيروح بدخل جوا النيوكليوس وببلش البروسيس. So this is the difference between those two اللي هو ال RNA and DNA. تمام؟ طيب إذا ال difference between RNA and DNA واضح. As we said, شوف عندنا examples على RNA and DNA viruses. We could see examples, as we said previously, على DNA virus. We have seen examples على DNA viruses زي ما حكينا. RNA viruses عندنا the virus that causes influenza, causes meningitis, that retroviruses that causes AIDS, and so on. للعلم الفيروسز don't only cause يعني diseases associated with the viral infection only. They could also cause cancer, for example. For example, retroviruses can cause T-cell leukemia. تمام. Papilloma virus is known to cause some type of other cancers, and specifically for female uterus and so on. So there are viruses that cause cancers as well as a secondary disease to their viral infection as well. طيب حكينا عن DNA viruses وعندنا RNA viruses. DNA in general are larger in size, and they do have inside them some enzymes and proteins. بينما ال RNA virus smaller, and they typically only have a reverse transcriptase فقط. They have reverse transcriptase enzyme plus their genetic material and the protein cover, whether it's a capsid or envelope. Okay, let's look at the viral life cycle. And the viral life cycle here starts with virus attachment on the human cell or the target cell or the host cell. تمام. بصير في attachment على receptor معين. This is the first thing, is the attachment. The second thing is the entry. Once it's attached itself, it goes, بصير لها engulfment, تدخل جوا السل من خلال entry. Once it's inside, now it has to be uncoated. So although it's not mentioned as a specific step, but we have to remove the capsid, the envelope first, and then remove the capsid to regenerate, just to get the genetic material. Genetic material كانت DNA بتدخل جوا الخلية جوا النيوكليوس مباشرة. إذا كانت RNA virus بده يصير لها reverse transcriptase to generate DNA, and then this goes inside the DNA to make the next process, which is replication and gene expression. And that replication and gene expression. So the gene expression that we see is the next step here, replication and gene expression. Once we make copies of the genome, now we start the process of making viral proteins through the translation process, transcription and translation process. And then once you have all the parts done, basically, which is making the protein and the genome, now next step is to do the assembly of those parts to generate more copies of the virus, and then the virus would basically leave as step to be released here, which is a release step of the virus. Now you have to remember that drug discovery would focus on any of these steps over here can be focused, but typically we have seen is drugs that affect release, drugs that affect entry, and drugs that affect genome expression. These are the most type of drugs that usually work on the three steps here, step 3, step 2, and step 5. But you can see drugs that affect all those type of steps in the viral life cycle. طيب خلينا نشوف examples على الفيروسز types. حكينا دي ان اي وار ان اي بنعرف، بس نشوف شو انواع الفيروسز دي ان اي والار ان اي what diseases they cause. For example, if we said DNA virus, papilloma virus that causes warts, and adenovirus that causes sore throat, conjunctivitis, and the herpes virus would cause chickenpox and shingles, herpes, as well as we said اللي هو genitalis herpes that's caused by herpes 2. We have RNA viruses, and the RNA viruses, for example, orthomyxovirus, which causes influenza disease. And part of it is the influenza virus, whether it is influenza A or B. We have arenavirus that causes meningitis and so on. So we have different diseases associated with different types of viruses. Now, let's take a look at the antiviral drugs to use to treat those viral infections. And the antiviral drugs, as we mentioned, are a class of medications that are used to treat viral infections. Antiviral drugs do not destroy the target pathogen. Instead, they inhibit their development. And so they won't cure you from viral infection, but they reduce the chance of getting symptoms or severe symptoms and severe complications. The first FDA-approved antiviral drug is called Idoxuridine. And Idoxuridine basically is a drug that's approved by FDA for treatment of herpes simplex virus, specifically herpes 1, and it was used only topically due to severe side effects. So هلا لما احط structure تبع الإيدوكسيوريدين مفروض انك تعرف later on why the idoxuridine structure is very similar to some other anti-cancer drug that we talked about, and that is the reason why you see severe side effects. It has to be used systematically, so it's not used systematically, only used topical, and that was 1963 when it was approved. Antiviral therapy that we have in general is limited for number of infections. وحكينا الانتيفيرال is not a very successful strategy to treat viral infections, unfortunately. The most favored way for pharmaceutical companies to stop viral infection, eradicate viral infection from a community is the vaccine development, not antiviral therapy development. And so a lot of companies would always go for vaccine option. If you can't get a vaccine option, then they focus more on antiviral therapy. For example, HIV, we don't have vaccine for it, so people are very eager to try to make drugs that treat these diseases or help and reduce the symptoms of this disease with antiviral therapy. لكن for example, if we look at COVID-19 بالبداية كان أول الشركات كلها كانت تبحث عن فاكسين وبدور على فاكسين، ما بتدور على antiviral therapy ببداية البانديميك، وهو السكسس كان فعليا في الفاكسين مش في الانتيفيرال ثيرابي للكوفيد-19. COVID-19 is caused by coronavirus. Coronavirus is an enveloped RNA virus, if we remember. تمام؟ طيب حكينا إذا الانتيفيرال therapy options are limited. The diseases that can be treated by antiviral therapy are HIV, herpes virus, hepatitis B and C, and influenza A and B. تمام؟ فالانتيفيرال therapy in general is not the first choice for eradicating or cleaning out a viral infection from a community or population. Let's look at the classification of antiviral agents or antiviral drugs. The classification of these antivirals based on what exactly they target, or what's their target in treatment of those antiviral infections, what they are exactly targeting in the virus. So the first class is antiviral agents that are interfering with viral nucleic acid replication. So they prevent the nucleic acid replication, and they can be subclassified into two subclasses: DNA polymerase inhibitors, which inhibit the replication of the DNA nucleic acid material in the DNA viruses, and then reverse transcriptase inhibitors, which works on RNA viruses by inhibiting the reverse transcriptase process of these viruses, so they inhibit the viral nucleic acid replication, RNA replication inside these RNA viruses. And these reverse transcriptase can be subclassified into nucleoside reverse transcriptase, and non-nucleoside reverse transcriptase اللي هم NNRTIs and NRTIs. And these are different based on the structure. In the structure, if they look like a nucleoside, they called as nucleoside reverse transcriptase inhibitors. If they don't have a similar structure to nucleoside, we call them as non-nucleoside. A second class is called antiviral agents that interfere with cellular penetration and early replication. We have virus uncoating inhibitors that inhibit the uncoating process of the virus to release their genetic material inside the host cell. And we have another class that we call a neuraminidase inhibitor, which basically we'll talk about it in a little bit, but these neuraminidase inhibit the release after we make copies of the virus. Now they are attached to the outside area of the cell, an extracellular part. They must be released to infect other cells. These neuraminidase inhibitors inhibit that process, stop that process. Other classes, we have protease inhibitor, and this class is one of the best examples على successful stories of generating antiviral therapy. Protease inhibitors has been very successful in treating HIV and hepatitis C virus. This is where the success happened mostly in the protease inhibitor. حتى بالكوفيد-19 كان في successful stories موجودة على targeting protease as an enzyme. في عندنا two drugs in COVID-19 that's called as Paxlovid, and the second drug is called as Remdesivir. These two drugs are required from you as a homework to figure out what's their component وشو الميكانيزم اللي بيشتغلوا فيه. تمام؟ Paxlovid is the commercial name that has two drugs inside it. You have to know the name of the two drugs, and then Remdesivir is the scientific name. You have to know the mechanism of action for that Remdesivir. يعني شو بيعمل بس بشكل عام مش مطلوب منك in details. شو الكلاس ايش بيعمل inhibition for what exactly. So this is as a homework important for you to do for COVID-19 drugs, just to enhance your knowledge or broaden your knowledge to other type of diseases. تمام. فزي ما حكينا protease are very successful. هدول are not important. I'm not going to talk about them in this class because of the limited time that we have for this semester. طيب خلينا نبلش ونحكي عن أول واحد اللي هو antiviral agents interfering with viral nucleic acid replication. The first one, which is the first subtype, is called the DNA polymerase inhibitor that works on the DNA viruses. وراح تشوفوا إنه في tables أحيانا بحطها فيها كثير أدوية بتشتغل بهذا الميكانيزم. I won't ask you about those except the ones that I will focus on in terms of medicinal chemistry. For example, we'll talk about Idoxuridine, Acyclovir, Valacyclovir. هدول just general knowledge within the class to know. That's all what you need to know. But these are the ones that we'll talk about and you should focus on. Idoxuridine حكينا is the first FDA approved antiviral agent in 1963, and the drug was approved for treatment of it's called herpes simplex virus infection, keratitis infection, topical application only due to severe side effects. بعدين اجى options have less side effects like Acyclovir or Valacyclovir. These can be used for treatment of herpes simplex virus 1, herpes simplex virus 2, varicella zoster virus, which causes shingles and chickenpox, and Epstein-Barr virus, which is not something you should know about. It's not important. The other drug اللي هو Valacyclovir used for treatment of herpes simplex virus 1, varicella zoster virus, and the cytomegalovirus as well. So these are the things that are used for treatment. Now let's look at the Idoxuridine. The Idoxuridine as a structure is very similar. I'm going to draw the structure over here. Very similar to a known anti-cancer agent. Let me draw the structure for you. Let's take a look at the Idoxuridine structure. This is the Idoxuridine. So if you look at the structure, the top part over here, let me use different color. So that part over here is very similar to a known anti-cancer drug that we talked about. If you switch this iodine with fluorine, this drug becomes as 5-fluorouracil, which is used in anti-cancer, anti-metabolite anti-cancer agent. So that's the structure, as you can see, is very similar to the fluorouracil. كنا نحكي 5-fluorouracil is a prodrug that needs to be converted to the active form, which you add a ribose sugar, deoxyribose, I'm sorry, and then you add the next step 3-phosphates to it. So the same thing here, you have to add 3-phosphate idoxuridine structure to be active as a drug, so it's a prodrug. And how does it work? Idoxuridine, basically it binds to the growing DNA chain, and it inhibits the DNA chain synthesis, as well as causes mutation with DNA, so it damages the DNA synthesis of these DNA viruses. تمام؟ طيب ليش له severe side effects? Because it resembles the natural nucleotide اللي موجود بالجسم زي اليوراسيل والثايميدين. الفرق بس وجود الايودين هون بدل هيدروجين باليوراسيل والثايميدين في عليها CH3. And so basically the drug can be used by normal human cells because it looks very similar to thymidine, deoxythymidine. And so basically you can trick this normal human cells to use it, which would cause severe side effects. That's why we don't use this drug systematically, as we mentioned. It has severe side effects. Okay, so we don't use that systematically. Now, other options that they came recently is Acyclovir. Let's look at the Acyclovir in the next slide over here, and we can see in the next slide of that Acyclovir. And Acyclovir structure-wise, this is the structure of Acyclovir. Let me just mark that Acyclovir structure. This is the structure of Acyclovir. The structure of Acyclovir is very, very similar to the known ligand that's or natural nucleotide that's called the deoxyguanosine. So it's very similar structure to forget about the phosphate. I'm not talking about the phosphate هلا تمام. So it's very similar structure-wise to the guanosine or deoxyguanosine. شو الاختلاف بينه؟ هاي الستركشر تبع الأسايكلوفير. Again, forget about the phosphate. I'm not talking about the phosphate right now. I'm talking about this part only. This is acyclovir. So if you look at the structure of acyclovir, it's very similar structure to what? To deoxyguanosine. الاختلاف بينه وبين الأسايكلوفير فقط هي الشوجر موiety. This sugar part اللي هو carbon 2' and carbon 3' are deleted in acyclovir. And this is very important because why it's important? Because if how the DNA chain grows is basically by addition of nucleotides to this 3' hydroxy. بصير الاديشن للnext nucleotide على 3' hydroxy. So if you delete that part, once this compound gets incorporated into the DNA, you will not be able to add more nucleotides on it. It stops the elongation of the DNA. وهلا راح نشوف بالميكانيزم as we mentioned. لكن كمان it's worth mentioning before we proceed إنه basically this drug is acyclovir is a prodrug. ليش prodrug؟ لأنه we need to convert acyclovir ل triphosphate form. So addition of this triphosphate is converting the prodrug acyclovir to the active drug. Once we added 3 phosphates, now it's the active form that can do the activity. طيب كيف نعمل addition of these triphosphates or 3 phosphate group على acyclovir? This is the structure of acyclovir. First, we use an enzyme that's called as thymidine kinase, which is existing as an enzyme. هذا الانزيم موجود بالفيروس نفسه، موجود بالسيل الهوست سيل. هلا الستركشر هذا لانه في deleted sugar or kind of different sugar than the natural one, the cellular kinase does not recognize this structure. So this structure needs to be first phosphorylation step هاي اللي بنحكي عنها. It can only be done, let me delete that, so let me use the pointer. So that first phosphorylation al hydroxy can only be done by the viral thymidine kinase enzyme, not the cellular thymidine kinase. So you add the first phosphate here using the viral thymidine kinase, and then the next 2 steps addition of second phosphate and third phosphate are done by cellular kinases. So the first one is done by viral, the next 2 steps are done by cellular kinases. طبعا هذا الحكي very good لانه هيك انا بصير عندي selectivity. The drug only works on the cells that are infected by virus لانه الviral enzyme is necessary for activation of that drug. So this is very good. Now this is very selective, that's why we can administer it orally, and it doesn't have so many side effects. And so basically this drug Acyclovir is very selective, needs a viral enzyme to be activated. It's activated to the triphosphate. Once it's activated to the triphosphate كيف راح يشتغل هلا الميكانيزم تبعه؟ زي ما حكينا راح يروح يرتبط مع DNA polymerase enzyme that is used to build the DNA chain of the copies of the virus, and it's being added lil DNA growing chain. Once it's adding to the growing chain, it terminates it because of the missing 3' hydroxy. Okay, because of the missing 3' hydroxy, it stops at this stage. There's no more growing on the DNA. There's no more elongation for the DNA happens. So it works by terminating the DNA chain, and it also competitively inhibits the DNA polymerase. It competitively inhibits the DNA polymerase because it competes with the natural nucleotides like deoxyguanosine triphosphate or deoxyadenosine triphosphate and so on. So it works by two mechanisms, but the main one is the chain termination after it's being added here. So again, just to summarize, this drug is a drug that needs to be activated. It's a prodrug need to be activated by viral enzyme to the triphosphate. وراح نشوف the next slide as we can see over here. So just to summarize, this is a prodrug that we said needs a viral thymidine kinase enzyme. It doesn't get activated by cellular thymidine kinase, only activated by viral thymidine kinase enzyme to be converted to the monophosphate, which would then be converted by father kinases enzyme to second phosphorylation and third phosphorylation to get the acyclovir triphosphate, which is the active drug. And this drug is very selective due to the viral thymidine kinase step and has potent activity against several DNA viruses, including herpes simplex virus 1, herpes simplex virus 2, herpes simplex virus 1 that causes cold sores, الحمو اللي بيطلع الثم. Herpes simplex virus 2 is the genitalis herpes, varicella zoster viruses, and some EBV are also used for treatment of these compounds. Now let's look at the structure of Valacyclovir. طبعا هون structures في كل اللي حطيناهم بالتيبل سابقا، ما بيهمني تعرفهم كلهم، بس لازم تعرف الايسايكلوفير structure. Idoxuridine حكينا عنه ورسمناه، والاخر واحد اللي هو الفالاcyclovir. الفالاcyclovir is very similar to acyclovir structure wise. As you can see, the only difference is basically the addition of this group or moiety here. So this group is added, and this group is basically a valine. This is an amino acid added there, coupled in an ester form مع الفالاcyclovir in an ester functional group, as we can see. الفالاcyclovir is added, as we can see, and to enhance absorption of this compound. لأنه absorption تبع acyclovir is about 30% at the best, and it's better with food usually. So acyclovir absorption is about 30%. Absorption تبع valacyclovir is about 50 to 60%. So it's much better absorption due to the presence of this amino acid. شو الادفانتج اللي انا باخذها من الامينو اسيد؟ في عندنا امينو اسيد كاريرز موجوده بالجي اي تي. We can use that amino acid carriers اللي موجوده بالجي اي تي to enhance the absorption of valacyclovir. So the oral bioavailability improves of the drug due to the presence of this valacyclovir. Now again, this valacyclovir is a prodrug. Yes, it's a prodrug that you first need to remove the valine moiety. First step, so it's a hydrolysis. Okay, this is the first step. The second step is to add 3-phosphate moiety to this to convert it to acyclovir triphosphate. Alright, this is the first group. هيك بنكون خلصناها اللي هي DNA polymerase. The first subtype of these nucleic acid replication inhibitors. Now let's go to the next step, and in the next subtype of compound or drugs, antiviral drugs, which is called as nucleoside reverse transcriptase inhibitors. So these are nucleoside-like structures. So بهمني تعرف فقط about two compounds, اللي هما azidovodine or azidovodine, sometimes called. That's why it's abbreviated as AZT. والnext one اللي هو tenofovir. And tenofovir is an antiviral drug also used for treatment of viral infections. Let's look at the structures of these drugs. And the structure of zidovudine, as we can see, is similar to a known natural nucleotide or nucleoside often. And the natural nucleoside is very similar structure-wise to is thymidine, deoxythymidine. This is very similar structure, deoxythymidine. ما بيهمني تعرف هدول الستراكشرات كلهم، بس بيهمني تعرف انهم they resemble the natural nucleotide existing in the body. Very similar structure. بيكون فيهم تغيير فقط في one atom, two atoms, and so on. But their structure-wise very similar. So they all work by the same previous mechanism we saw in the DNA polymerase. لأنهم similar to the natural ligand. They would trick the viral enzymes to use this inhibitor or this compound to build their DNA chain, and that would cause termination of the DNA chain, elongation. تمام. So they work by similar mechanism to DNA polymerase. فقط هم بيختلفوا لأنهم بيشتغلوا على reverse transcriptase enzyme, not on the DNA polymerase enzymes. بس خلينا نحكي عن أول واحد اللي هو الزيدوفودين. But look at the structure of zidovudine. As we said, it's very similar to deoxythymidine structure-wise. So it's almost exactly the same structure. The only difference is instead of the 3' hydroxy, we have an azide group or azide group. We have an azide group here that we see, and the azide is something like this, looks like this, 3 nitrogens. It's called as an azido or azide group. Azides are not very stable. In general, you don't see them in drugs. And azides usually bile for they're photosensitive as a drug. They're heat sensitive, light sensitive as well. So they're not, and they can be easily replaced by nucleophiles. So they're not typically used. Zidovudine is basically the way it works is by being, it has to be converted to the drug. So it's a prodrug first of all. So it's a prodrug زي اللي شفناه الدرج اللي قبل شوي اللي هو Acyclovir أو Idoxuridine or so on. So it's a product that needs to be converted by addition of 3-phosphate groups al hydroxy. And once it's activated by addition of 3-phosphate groups, now the drug would go and bind through the reverse transcriptase, through the reverse transcriptase to build the DNA, and that causes the DNA termination. It also works by competitively inhibiting this. It's a competitive inhibitor, reversible competitive inhibitor at reverse transcriptase as well, because it competes with the natural ligand زي deoxythymidine. So it works by two mechanisms similar to Acyclovir or the other drug that we talked about, Idoxuridine. تمام. هلا مشكلة الزيدوفودين is a drug that causes a lot of side effects. It can be used for treatment of HIV, and this is typically what they use it for, although it has many severe side effects include myelosuppression, which cause anemia or neutropenia. It causes anemia and neutropenia. So why does it cause that? لأنه it's very similar structure to the deoxythymidine. So normal fast growing cells can use this drug to build their DNA, and that could cause cytotoxicity for them. So that's why you see myelosuppression, you see nausea, you see vomiting, you see side effects similar to anti-cancer drugs, because it can trick normal cells, human cells, to use this drug in their DNA synthesis, and that would cause severe side effects. زي الإيدوكسيوريدين بس يعني أخف شوي side effects more or less. تمام. It's used still for treatment of HIV, part of HIV regimen, but not the first choice usually. If the other drugs didn't work for resistance or other type of issues, then they switch them to zidovudine or azidovudine. طيب هذا الدرج بس راح احكي عنه بالnucleoside reverse transcriptase inhibitors. النكست سلايد راح احكي عن non-nucleoside reverse transcriptase inhibitors. And the non-nucleoside reverse transcriptase inhibitors are compounds that inhibit reverse transcriptase not on the same site, مش على نفس الاكتيف سايت اللي بيرتبطوا عليه النيوكليوسايد ريفيرس ترانسكريبتيز انهبيترز او بجنرال بشكل عام اللي هم نيوكليوسايد الناتشرال نيوكليوسايد اللي موجودين بالجسم وين بيرتبطوا بالريفيرس ترانسكريبتيز. هدول non-nucleoside reverse transcriptase don't bind on the same site. Let's take a look at the enzyme. Let's look at the reverse transcriptase And the reverse transcriptase has two sites. One is called an active site that does this building, DNA building. Tamam. And the other site over here is called as allosteric site. And allosteric sites are sites that are not important for the activity itself in terms of, it's not the active site where the enzymatic reaction happen, but it does control the activity of the active site. So if you have a compound bind to this as an inhibitor, it disturbs the shape of the active site. So it disturbs the shape of that active site over here, and that would destroy the activity of the enzyme or reduce the activity of the enzyme. And this is exactly what these non-nucleoside reverse transcriptase inhibitors work on. These compounds would come and bind the allosteric site over here, so they reduce the activity of the active site, reduce the enzymatic activity of the active site, and so they inhibit the enzyme replication process. تمام؟ طيب إذا مهم نعرف إنه هذول non-nucleoside reverse transcriptase, first of all, they don't bind to the active site, they bind to the allosteric site. That's how they work. And because of that, these compounds, for example, one of them is nevirapine, and we have dilapiridine as well as efavirenz. These are three compounds. They bind to the allosteric site. Because they bind to the allosteric site, there is consequences for that. The first consequence, اللي هو drugs here, the nevirapine, is very potent drugs that can, in the smallest concentration, can reduce the viral growth. تمام. فالnevirapine is very, very potent drug, and it's very safe drug because they don't bind على active site. They don't look like the natural nucleotide or nucleoside الموجودين بالجسم, and so they don't cause severe side effects. So they're very potent and low side effects. These are the two advantages for the non-nucleoside reverse transcriptase. Again, they're very potent and low side effects. لكن the main disadvantage of non-nucleoside reverse transcriptase inhibitors اللي هو development of resistance. These drugs would probably see a quick development of resistance if they're used as single agents. So they're not used as single agents, they're almost always used as a combination of two with another drug that works in a different mechanism. تمام? For example, nevirapine, as we mentioned, works by inhibition of allosteric site. You could see some resistance develop quickly for that. And the reason why those enzymes can develop resistance quickly لأنه هذا السايت مش الأكتف سايت فبيقدر يغيروا عليه ميوتيشن بسهولة ويمنعوا الارتباط تبع النيفرابين. فبالتالي non-nucleoside reverse transcriptase inhibitors only not given as single drug. They're not given as single drug always. They're given as combination to reduce chance of resistance development. تمام? So again, just to see here, the nevirapine structure, focus on this nevirapine. It's not a nucleoside-like, so it's a non-nucleoside. It's a dipyridodiazepinone derivative that binds directly to reverse transcriptase. It blocks reverse transcriptase activity by causing disruption of enzyme's catalytic site لأنه بيرتبط على allosteric site. And the activity of nevirapine does not compete with the template or nucleoside triphosphate. So it doesn't bind to the active site, it doesn't compete there. So it doesn't bind to the same site. Nevirapine exhibits strong antiviral activity against HIV therapy, but it's never used alone. It's used always as a combination. And I have a question. Is nevirapine a prodrug? It's not a prodrug. It's an active drug that doesn't need activation. It has very limited side effects, very small side effects or benign side effects that are very simple, like nausea, vomiting, and so on. But none of these side effects is severe side effects. تمام? So this is a good choice, but in terms of using it as a combination for treatment of HIV and other viral infection. طيب هلا هيك بنكون حكينا عن النيوكليك acid replication inhibitors in general, سواء كانوا DNA polymerase أو reverse transcriptase inhibitors, وحكينا عن two types, nucleoside و non-nucleoside. خلينا نحكي عن another class of drugs اللي هم antiviral agents that interfere with cellular penetration and early replication. وحكينا عنها في drugs that interfere with the uncoating or drugs that interfere with the release of the drug تمام from the cell. We have two classes of drugs that راح نحكي عنهم بهاي الكلاس subclasses اللي هم الامانتيدين والريمانتيدين. They work on influenza A. وراح نحكي عن oseltamivir and zanamivir. These two drugs works on influenza A and B, and they work by different mechanism than amantadine or amantadine. Amantadine or amantadine work through inhibition of basically uncoating process. بينما الأوسيلتيمافير والزاناميفير they work by inhibition of the release of the virus from the human cell or the host cell. Let's take a look at their mechanism, how they work exactly. Amantadine and rimantadine they work by inhibition of the uncoating process. حكينا الانزيم بده يصير له اول شيء binding وبده يدخل داخل السيل بالانتري يدخل جوا، بعدين بدنا نفكك الكوت الخارجي مشان نطلع ايش؟ النيوكليك اسيد ماتيريال تبعته. هلا هاي البروسيس usually happens by M2 channel or a channel موجودة على outer part على الكابسيد that allows proton to be transported inside to increase the acidity of this coat and make holes on the acidity of the media inside this capsid and make holes inside that to allow the whole genetic material to leave. Amantadine and rimantadine work by inhibition of that M2 channel basically. So they're like a channel blocker that block these channels and inhibit the proton transfer inside the viral cell, so they prevent the reduce of the pH and creating holes or channels to allow for the genetic material to come out. تمام? So this is the first two drugs, amantadine or rimantadine. The second two drugs اللي نحكي عنهم اللي هم oseltamivir, which is known as Tamiflu, دواء مشهور جدا يستخدم للتريتمنت of influenza. It's not a very successful and I wouldn't call it very not efficacious drug لأنه it only reduces the symptoms by 1 to 2 days. That's all what it does. But still, it's a good option to have. So oseltamivir and zanamivir are two drugs that work in the inhibition of enzyme that we call it as neuraminidase. وهذا الانزيم موجود على الفيرال cell على الفيرال coat, outer coat, usually allows the release of the virus from the extracellular part of the human cell or the host cell by breaking the bond between the viral cell and the human cell. وراح نشوف هلا in details how it is. Let's take a look at the structure over here. The structures of the two drugs are amantadine and rimantadine. You can see very similar structures. The only difference between amantadine and rimantadine is the presence of the methyl. They have a cage-like cyclic structure in both amantadine and rimantadine with an amine outside. وهلا راح نحكي عنهم in terms of biological activity and medicinal chemistry. Take a look at the zanamivir and oseltamivir. The two structures here, zanamivir is older than oseltamivir, and the zanamivir you can see it's a sugar-like structure, as we can see 6-member ring في واحد منهم oxygen. So this is works by inhibition of اللي هو neuraminidase enzyme that cuts the connection or the bond between the virus والhuman cell. خلينا نطلع in details على amantadine first and rimantadine. Amantadine is a drug. A story behind its discovery. Amantadine was initially found as antiviral drug. As an anti-Parkinson drug. So it's a drug that's used for treatment of Parkinsonism or treatment of Parkinson disease. وكان مستخدم من patients بالباركنسون اللي بيستخدموه بدخل على CNS وبيعمل الافكت تبعه. لقوا انه بهذا البيشنتس فعليا their chance of getting viral infection, specifically influenza, is very small. تمام. فلما حكوا انه هذول البيشنتس اللي بياخذوا هذا الدواء الامانتادين اللي عندهم باركنسون، بس فعليا من اقل الناس اللي بصير عندهم انفلونزا بالاعمار خصوصا الكبيره، بلشوا يعملوا further clinical studies and they found that amantadine works as antiviral agent, very potent antiviral agent, works by inhibition of this M2 channel that we talked about, ion channel. تمام. وبعدين was approved by FDA for the use as antiviral drug for treatment and prevention of influenza. So it's used for both treatment and prevention of influenza infection. كيف بيشتغل؟ حكينا هو بيمنع uncoating process as we mentioned, and it works through the inhibition of we call blocking the M2 matrix channel, so it reduces preventing the pH shift required for the uncoating process. تمام؟ طيب طلع الستركشر تبعه. هلا نحكي chemical structure and next structure activity relationship study. If we look at it, this is the structure of amantadine and amine على cage-like structure, and this cage-like structure is called as adamantane. adamantane. So okay, so the adamantane over here, the name adamantane refers only to this part اللي هو الكيج like structure without the amine. إذا بنضيف عليه amine صار اسمه amantadine. Amantadine. تمام. So adamantane is the cyclic cage structure. Hydrocarbon cyclic cage structure is called as adamantane. أنا مش حاب أكتب لأنه عندي الكتابة صعبة شوي، بس هي اسمه as adamantane. تمام. هذا السايكليك كيج ستراكشر اذا ضفنا عليه صار الامين صار اسمه amantadine as we see over here. تمام. طيب هلا structure wise الامانتيدين as we can see has an amine. هاي الامين can be modified with various type of modifications. Some modifications would enhance the activity or keep the same activity, some would reduce the activity. الامين you can add عليها alkyl groups سواء CH3, ethyl, methyl, propyl, so on, and that would exhibit antiviral activity similar to the original اللي هو الامانتيدين. تمام. بس اذا بدك تضيف عليها acetyl group like this يعني تصير زي amide, this would destroy the activity. And if you try to replace amine with sulfur, oxygen, nitrogen, or other halogens, that would also reduce or destroy the activity, make an inactive compound. This is generally what you need to know about amantadine. So amantadine is initially discovered as Parkinson's drug, and then later on was found to have antiviral activity, and nowadays it's approved for treatment of influenza virus and prevention of influenza virus. So it's used for treatment of all type A strains of influenza virus, سواء كان type A1 أو A2. وحكينا إنه أصلا هو كان for treatment of Parkinson's disease. لأنه كان used for treatment of Parkinson, that means the drug crossed the CNS, so that the side effects of this drug is related, are central side effects because they can cross the blood-brain barrier or reach the CNS. So these are central side effects, and they include nervousness, confusion, headache, drowsiness, insomnia, depression, and hallucination. So they're relatively severe side effects. هلا الدواء الثاني اللي انا ما حكيت عنه اللي هو الريمانتادين، ولو بدي ارسم الستراكشر تبعه ممكن احاول ارسمه هون بالقلم، بس يمكن صعب شوي ارسمه على الجهاز اللابتوب، بس بدي احاول ارسمه قدر الامكان. طيب عندنا هون بده يكون في مثل so you would have to do that over here, and then we have over here. So that structure with the nitrogen is considered as amantadine. صح؟ هلا الريمانتادين structure مختلف عنه، بدل في النيتروجين هون ضافوا 2 atoms صارت nitrogen NH2 هون و CH3 over here. This is called as ريمانتادين. تمام. اسمه as ريمانتادين، عفوا ريمانتادين هو اسمه بالايه. I'm sorry. ريمانتادين. تمام. ريمانتادين as a structure is very similar to amantadine, except that it does have an extra methyl, and that drug is designed to reduce CNS penetration, and so basically reduces side effects. So rimantadine is the same activity as amantadine, but less side effects. It doesn't cross the CNS as good as amantadine because it is a little bit more non-polar structure, and so the drug has less side effects compared to amantadine, but it's the same activity. اوكي، سو هيك بنكون حكينا على الامانتادين والريمانتادين. خلينا نحكي شوي عن اللي هم النيوروامينيديز inhibitors. طيب نحكي شوي عن neuroaminidase inhibitors. Neuroaminidase inhibitors, these are compounds that inhibit the viral neuroaminidase to prevent the virus from leaving the host cell and infecting other cells. حكينا انه بعد ما يصير في assembly للviral proteins as we can see, now the virus will leave. When it leaves, it still will be connected. There will be شيء بنسميه hemagglutinin as well as sialic acid or a sugar moiety جاية من human cell or host cell attached with the hemagglutinin part that exists on the virus itself. We have an enzyme على viral cells that we call as neuroaminidase. وظيفته انه يحطم هاي الرابطة between sialic acid sugar as well as the hemagglutinin to release of new virus that goes and infect other cells. Look at the structure. This is the structure of sialic acid attached to glycoprotein lipids موجود على الفيرال سيل and وظيفة النيوروامينيديز أو أحيانا بسموه سياليديز لأنه هو بكسر رابطة sialic acid مع glycoprotein, and this enzyme would destroy, and this glycoprotein lipid part of the virus would leave and allow the virus to leave the cell or normal cell. So neuroaminidase catalytically cleaves glycosidic bonds, sugar bonds between terminal sialic acid residues and adjacent sugar and hemagglutinin that exist على viral cell. This is very essential neuroaminidase to allow the release of these viruses to infect other type of cells. So what these inhibitors do, for example, Tamiflu or Oseltamivir, is they inhibit this process. They inhibit this neuroaminidase process. So the virion or the virus that's outside the cell but is still attached to the cell would stay attached to the cell, and there will be no viral release. This drug, Oseltamivir, or also what's known as Tamiflu, inhibits the neuroaminidase enzyme, which is expressed on the viral surface, and the enzyme promotes the release of virus from infected cell. What is used for Tamiflu? Tamiflu, as we all know, used for treatment of flu virus. It reduces the recovery time by 1 to 2 days only. So it's not super efficacious drugs, and it reduces the symptoms, but it doesn't have efficacy على ال death rate that coming from اللي هو ال flu infection. However, it's still useful to reduce the symptoms in general. Very small side effects, not much side effects, really simple side effects. And as we look at the drug over here, the drug has a 6-member ring similar to the sialic acid, as we can see, and it resembles the sialic acid structure in many ways. So that's why it's a competitive inhibitor of this neuroaminidase enzyme. It competitively inhibits this enzyme by blocking the active site and preventing sialic acid binding to it. And so Oseltamivir structure, as you can see, very similar. It has, instead of the carboxylic acid اللي موجودة عندنا هون, موجود عندنا is an ester, and that ester is made to enhance the oral absorption, to enhance cell permeability. بالتالي it's a prodrug that needs to be converted by plasmaesterases to the carboxylic acid or free carboxylic acid. Oseltamivir or Tamiflu has to be given within the first 2 days of appearance of symptoms to have a good activity or biological activity. So this is the main one that we should learn about as a neuroaminidase inhibitor. Zanamivir مش راح احكي عنه لانه older generation هو used as inhaled only agent, and it's not used as for oral absorption or oral administration. طيب نحكي عن the last class of compounds in the next slide, which is طيب نحكي عن protease inhibitors وهم last class of antivirals that we'll talk about. And these drugs are compounds that have the ability to inhibit what we call as protease enzyme. Protease enzyme is an enzyme that cleaves viral polyproteins into individual functional HIV proteins and enzymes. هلا بعد المسنجر RNA ما يطلع ويصير له translation process, it will be translated to a very large protein, huge protein that needs to be cut into smaller pieces that are functional proteins and enzymes for this virus, whether it's an HIV or whether it's COVID, whatever it is. وظيفة البروتياز enzyme انه يحطم البروتين الكبير جدا هذا اللي poly huge peptide لsmaller pieces من الاميد bond. So بكسر الاميد bond فعليا وبيحطمها لsmaller proteins و smaller enzymes. بالتالي إذا targeting this protease enzyme could have a potent antiviral activity لأنه أنت بتمنع تصنيع individual proteins والenzymes اللي بيحتاجها الفيروس. And the way it works by a presence of a serine and a serine amino acid. That serine has an OH, as we all know, and that OH would attack the imide bond and destroy that imide bond into carboxylic acid. So بصير في عندنا nucleophilic attack على الكربونيل، تطلع الكترونات بينتج عندنا اللي هو transitional state اللي بنسميها as, if you remember, quaternary. حط serine NH and whatever that peptide, there's a peptide. So this is the transitional state, or what we call sometimes as اللي كنا نحكي عن tetrahedral intermediate that would collapse down to release a nitrogen and then also there is a water contribution and so on to get the the carboxylic acid plus the NH2 part, the amine, so the peptide would be break into 2 bonds. So that transitional state is the target for these protease inhibitors. They mimic the transitional state structure. So look at the transitional state, does have hydroxy. So you will see that all those antivirals that work through protease inhibition has a moiety that we call as ethylene hydroxy, or sometimes this is called as statin hydroxy. اسمهم كمان statin hydroxy. هم عبارة عن ethylene hydroxy ethylene moiety or part of the inhibitor. This is an example على one of the inhibitors. So as you can see, instead of in this case an imide bond between proline or phenylalanine, 2 amide bonds that were 2 amino acid between them, 1 imide bond راح تتحطم بprotease enzyme. Let me delete those. So that bond will be cut by this protease enzyme. You can see that this amino acid اللي هو phenylalanine proline cut by the protease enzyme راح نصنع بداله inhibitor. This inhibitor here that has the hydroxyethylene moiety. This is one of the inhibitors. راح نشوف more inhibitors later. It has very similar structure للphenylalanine صح؟ It has very similar structure للبرولين شوية مختلف عن البرولين بس فيه النيتروجين. لكن اللي بوصل بيناتهم مش imide bond زي ما هون موجود عندنا. اللي بوصل بيناتهم فعليا راح يكون اللي هو هاي الهيدروكسي ايثيلين اللي موجوده اللي حكينا عنها ستاتين هيدروكسي as well, او الهيدروكسي ايثيلين moiety that we see. So they resemble the transition state in the fact that they have hydroxy, so they are transition state mimics, and they resemble the whole peptide-like structure. So they're peptide-like compounds, and they have hydroxy ethylene moiety or statin hydroxy as well additionally. So these drugs are potent in inhibiting protease inhibitors. They have very limited side effects, not much of side effects, because they target protease enzyme that's selective for protease in the viral proteases, not the human proteases. However, the disadvantage of these compounds are peptide-like structures. So they can have low pharmacokinetic, not ideal for absorption and distribution, and bad pharmacokinetic properties. In addition, they are slow binding inhibitor بنسميهم أحيانا. ليش slow binding inhibitors؟ لأنهم they resemble transition state. لازم يرتبطوا على الإنزيم لما يكون ready in the transition state shape. So they are transition state mimics. So the consequences of slow binding inhibitor, that means the drug has to be administered at the right dose interval. It's very important the patients to get the medication on the right timing they're given to them, right dose intervals. كل 8 ساعات كل 8 ساعات كل 12 لازم كل 12. If they miss a single dose, that would cause a huge drop in their efficacy. That's why في بعض البروتيز inhibitors بالHIV therapy بيحاولوا يعملوهم as an extended form, IM injection ينعطوا للpatients for that will stay with them for over a week or 2 or 3, so they don't have the issue of missing a dose or so on. وحكينا البروتيز inhibitor عملوا huge difference بالHIV treatment, عملوا huge difference بالhepatitis C treatment, and they made a difference in the COVID-19 treatment as well. So these are important drugs or class of drugs that we should really be thankful of. We have many examples على البروتيز inhibitors هون موجودين زي الريتونافير and النيلفينافير and so on. ما بيهمني تعرف الديتيلز كلهم، بس نعرف انهم بروتيز انهبيترز. ما راح احكي عن ستراكشر وايز تبعهم كثير. نطلع على التيبل هون كمان في عندنا examples على different type of protease inhibitors. So we have examples here على البروتيز inhibitors زي الريتونافير، الإندينافير, is Acyclovir as well as lopinavir as well. You can see that the structure of these compounds, more or less all of them has this hydroxyethylene moiety, and they all or less have peptide-like structure. So they're peptide-like structure, as you can see, and they have this hydroxyethylene moiety that resembles the transition state mimic or to mimic transition state. You see these are all have this hydroxyethylene moiety, as we can see. and the whole hydroxyethylene in their structure. You have another hydroxyethylene and so on, more hydroxyethylene in all the structure, and all of them are peptide-like structures. Look at the structure of Acyclovir, and this is the last thing I will talk about today for the antiviral agents. This is the first proteasome inhibitor approved in the US in 1995, and it's an amide derivative or carboxamide. This is called like a carboxamide moiety over here, carboxamide derivative. It's designed specifically to inhibit HIV protease, but preventing post-translational formation of viral proteins. It contains the hydroxyethylene moiety that we talked about. This is the hydroxyethylene moiety over here, rather than the phenyl proline cis bond. حكينا انه originally في بالstructure phenyl proline targeted by protease. هي الامide bond between phenyl and proline. هاي مش موجودة بهذا الستركشر، بس موجود فيه الفينيل انالين لايك والبروين لايك structure موجود فيه، بس ما فيها amide bond to be cut by this protease. They just sit competitively inhibit this protease enzyme without getting chewed up or cut by this اللي هو protease enzyme. So it looks like a normal substrate for the HIV protease. It does inhibit this competitively on active site of the active site and so on. Acyclovir is used in the treatment of HIV infection in addition to other medication. دائما بال HIV patients يفضل أن تستخدم combination of 2 medications or more، حتى في أحيانا بسموه triple therapy. The side effects include GI disturbance, headache, rhinitis, diarrhea. Very simple side effects, not something to worry about. هيك بنكون خلصنا كل الانتي فايرال ثيرابي والميديكيشنز تبعون الانتي فايرال. ان شاء الله بتكونوا استفدتوا من موضوع الانتي فايرال اخذتوا ايديا بشكل عام من الانتي فايرال. ولا تنسوا انه انا اعطيتكم هوم ورك لتو دراجز اللي هم باكسلوفيد والريمديسيفير to look at to try to identify what their class and what are the components of those two drugs. ويعطيكم العافيه.